Hi, we're going to learn another technique for dividing, and we're going to use this a lot in future sections. This is called synthetic division. So these are kind of the mechanics behind it, this video is. So we're going to look at how do I set up a synthetic division problem, how do I actually use the synthetic division process, and then how do I rewrite my quotient back into polynomial form so I get an understanding of what I have. All right, so let's get started with this. Okay, setting up synthetic division, you want to make sure that your polynomial is in descending order. Okay, we're not going to have any x and y's, we're only going to have one variable, so it needs to be in descending order. Okay, you're going to want to fill in any missing terms with zeros, just like we did in long division. And then you're going to want to take just the coefficients, just let go of the variables, and just write the coefficients in a row. Okay, that's the coefficients of the dividend. Okay, that's the polynomial that's being not being divided by. It's the one that we're actually dividing. Okay, then the divisor, we're going to place the divisor outside the box just like we did with long division. However, if we're told that we're dividing by x minus 2, for the same reason how we find a vertex, how we find a zero, how we find an intercept, you're going to actually divide by the opposite sign. So in this case, if we were asked to divide by x minus 2, then we would actually place a positive 2 outside as our divisor. Okay, so let's try and just set these up. Okay, so just this is the dividend, and this is the divisor. Okay, so the divisor goes outside the box and we flip the sign. See how that's a plus 5? We're going to divide by a negative 5. Now we're actually going to draw an upside down division box like this. And then we're going to place our coefficients. We're going to check to see if they're in descending order. So an exponent of 2, an exponent of 1, an exponent of 0. All right, and then we're going to check to see if we have any missing. So this is 2, 1, 0, so we're okay. So we're going to put our coefficients in a row here. Okay, right? That's how we set it up. Okay, so why don't you try and set up number 2 here as part of your video questions and come back and see if you got it right. All right, okay, inside my box, I'm looking to see if I'm in descending. 4, 2, 1, 0. Okay, I'm in descending. And then I want to check to see if I have any missing terms. I'm missing an x cubed term, so I'm going to go 1, 0, 3, negative 10, and 5. And then out in front here is a positive 2. It's the opposite of that. Okay. All right. Now we're actually going to use synthetic division. Okay, so the first thing we have to do is set it up. All right, so I'm going to look at my dividend, check to see if I'm in descending order. 3, 2, 1, 0, and I don't have any missing powers. So inside my box is going to be a 2, a negative 13, a 26, and a negative 24. Okay, my divisor is going to be the opposite of negative 4, so that's positive 4. Okay, now here's the process. We're going to bring down our 2. Okay, then we're going to multiply this coefficient 2 by the divisor 4. So 2 times 4 is 8, 8 plus negative 13 is negative 5. Okay, that's the add the two together. Okay, now I'm going to repeat steps 2 through, actually that should be 2, 3, and 4, okay, or 3 and 4. So I'm going to take the negative 5 and I'm going to multiply it by 4. That gives me negative 20, and I'm going to add it to 26, so that gives me positive 6. Right? Now I'm going to repeat that again. I'm going to go 6 times 4 is positive 24, and I'm going to add it to negative 24, and it gives me a 0. And I always box that last number off because that's my remainder. Okay? So I've gone through steps 3 and 4 repeatedly all the way across the row. Okay? Now you have to realize what it is that we have here. We've actually divided through by x minus 4. Okay? If you notice in all of your other problems, whenever we divide through by an x, our quotient was always a degree less than our dividend. So now when I rewrite this back in polynomial form, this has a power of not x cubed anymore, but of x squared, and then minus 5x plus 6, and then our remainder is, which we wouldn't normally write like this, but I just wanted to show you all the different pieces, would be like this, x minus 4. I want to get rid of that long line here. X minus 4, okay? So it's important to remember a couple of things. This last column here, that's your remainder. If this is 0, then this original factor here, this original like binomial, the divisor, is a factor, and 4 is a solution of this higher order polynomial. We're gonna learn about that in just a minute. Okay. All right. So let's try another one here. We have to set it up. So I check my descending order, 3, 2, 1, 0. I check to see if I'm missing anything. 3, 2, 1, 0. I'm not missing anything. So now under my box is a 2, a 3, a negative 4, and a 15. And outside my box is negative 3. So in order to start the process, I have to bring the 2 down. 2 times negative 3 is negative 6. And now I add these. That's important. It's add. So I get negative 3. Negative 3 times negative 3 is positive 9. 9 plus negative 4 is 5. 5 times negative 3 is negative 15. And I add and I get a remainder of 0. Okay? So now I'm going to take my quotient and rewrite it in polynomial form, and I get 2, no longer x cubed, but x squared minus 3x plus 5. And I have a remainder of 0, so that means this is a x plus 3 is a factor, negative 3 is a solution, and f of negative 3 is 0. Okay. All right. So why don't you try this one on your own, okay? And then come back and see if you got it right. Okay. So I'm going to set this up. I'm going to divide by 2. That's the opposite of my divisor. I have a 6 and a negative 8, but I'm missing x squared right here. So that means I have to put in a 0. That's a common mistake that students leave out. And then I have a 12 and a negative 14. Okay. I bring down my 6 and I multiply. That's 12. 12 plus negative 8 is 4. I multiply 4 times 2, that's 8. 8 plus 0 is 8. Then I multiply 8 times 2, that's 16. 16 plus 12 is 28. Right? Then I multiply 28 times 2, and I get 56. And 56 minus 14 is 42. Okay? So I started with x to the fourth. That means this quotient is 6x cubed plus 4x squared plus 8x plus 28 plus, see now this is not 0 anymore, right? This is a number. So this is plus 42 over your original binomial, x minus 2. And that's simplified using synthetic division. Okay? All right, why don't you try this one? Well, no, I'm going to do this one with you because it has a coefficient on the x here. All right, so here's what we're going to do first. We're going to take this 2x minus 1 and we're going to set it equal to 0, and we're going to solve for x. This is my divisor in the synthetic division. Okay, so this goes outside my box. So this is a half. Okay. Now I'm going to check for any missing terms. Okay. So I have a 3, a 2, and a 1, but I don't have a 0. So I have a 4, a negative 6, a 4, and I have to put in a 0. So I'm going to bring down my first coefficient. Then I'm going to multiply 4 times a half. That gives me 2, and I'm going to add it to negative 6. That gives me negative 4. Then I'm going to multiply negative 4 times a half. That gives me negative 2. And I'm going to add those together, and I get positive 2. Then I'm going to multiply 2 times a half. That's 1. And I'm going to add it, and I get 1. Now this is called a depressed polynomial. We depressed it by 1 degree. So this becomes 4x, not cubed, but squared, 1 less than that, minus 4x plus 2 plus 1 over x minus a half. Okay? X minus a half. You have to use this in your remainder, okay? Not this one. Okay. All right. So there's a couple cool things to know from the remainder of synthetic division. If your remainder is 0, then that divisor, that binomial, is a factor. That's going to be really important when we go to solving higher order polynomials. If the remainder is 0, the divisor is a root, so that means whatever number you're dividing by, say it's 1, 1 would be a root or a solution. And then the function evaluated at that divisor, okay, that is the height of the graph. So that's always going to equal the remainder, okay? And we're going to use that. It's a fast way to evaluate, okay? All right, so let's try this one more time. We'll do this together, and then we'll answer the questions. Is the divisor a factor? Is the divisor a root? And then find f of the divisor, okay? So I'm going to put a 1 out as my divisor. It's the opposite of this one right here, opposite. I have 3, 2, 1, 0. Those are my powers, and I'm not missing anything. So I have a 1 here, and this is 3, negative 6, 2, and 3. I bring down my first one. 3 times 1 is 3. I add it to my second column. Negative 3 times 1 is negative 3. I add it to my third column. Negative 1 times 1 is negative 1. I add it to my final column, and that gives me a 2. Okay? So, is the divisor a factor? Well, look here. Is the remainder equal to 0? No. So it is not a factor. Is the divisor a root? Well, is that 0? No. So is remainder a 0? That's what you look for. Doesn't equal 0, so it's not a root or a solution. And then find f of the divisor. Well, our function evaluated at 1 is equal to 2. So that means the height of the graph is 2 units above the x-axis. All right, this is going to be our assignment. Thank you for listening. I'll see you tomorrow.